Hello to everybody. Today I'm going to present our work called Filtering Conversation by Dialogue Acts Label for Improving Corpus-Based Convergence Studies by Simone Fuscone, Laurent Prévot, and Benoit Favre. This work deals about convergence. Convergence say that during a conversation, two speakers tend to modify their speech style in order to become more similar to their interlocutor. For example, a speaker could modify some parameters of his speech production, like energy, pitch, or speech rate, to adapt to his interlocutor. What we want to do in this work is to explore some aspect of the dynamic of convergence by the use of dialogue acts. In particular, dialogue acts will be used as a way to control the variability of natural conversation, as we want to study convergence in a natural conversation framework. Our approach consists in taking each conversation of the corpus and dividing in two halves of the same length, same temporal length. Compute average values of the two speakers produced in the first and second half. For simplicity, we can call the two speakers speaker A and speaker B. So what we want to do is to check if in the second part of the conversation, the distance between the average values produced by the speaker A and speaker B, the Euclidean distance between them, decrease compared to this Euclidean distance computed in the first half of the conversation. The average is the average of the mean values computed per each turn produced by the speakers, while the variables that we scrutinized are energy, F0, and speech rate. The dataset that we used is called the switchboard, and it contained 2,438 telephonic conversations for a total of 543 speakers in American English. Here, to the participant, were asked to discuss a pre-assigned topic. In addition to the switchboard, we use a subset of the switchboard that is called NXT that contain human annotation of dialogue acts. Is a subset that contains 642 conversations. So it's smaller, but it has the advantage of containing dialogue acts by human annotators. The general idea of the use of dialogue acts is that different speech activities can have an impact on the future extracted, on the extraction of the futures. For example, you can see in this example that a statement could be very different from a back channel. And so this could, taking all the speech activity as one object, treating it as one object, could produce some noise in the computation of the average values that we want to compare. So what we done was to choose the majority class of the dialogue acts that form the human annotation, the subset of the human annotation. And so we choose to compare statement, opinion, and back channel that represent the 71% of the dialogue acts of the switchboard. This way we could apply our approach, so predict the distance between the two speakers using as a predictor, as a fixed effect, the number of the halves, so first half and second halves of the conversation, and as random effect, the topic of the conversation and the ID of the speaker A and speaker B. In this slide, we are going to report just results that show significant results, but we compared different kind of subset, the entire switchboard and the subset NXT, taking all the dialogue activities without a distinction in the computation of the average. And then we compared similar speech activities of the subset of the NXT that are back channel, statement, and opinion. As we can see, we report just statistical significance. Energy and speech rate exhibit a decrease in the second half of the conversation. In particular, energy has a strong effect compared to speech rate. For the case of back channel, we found a significant effect for energy. This is due maybe because the computation of speech rate is very sensitive to the length of the turn that we are computing. So back channel are very short, formed of very short utterances. So this introduces a lot of noise in the computation of speech rate. As we can see, even though we reduce the number of data set, the number of data points to compute the average values in the first and second half, we could see that even though in the case of back channel and the statement, we found still significant effect. So in order to expand this work, we introduced in this work dialogue acts in order to automatically tag a dialogue acts tagger in order to automatically tag the speech activities of the speakers. As the segmentation of the tarn as provided by switchboard doesn't match the dialogue act segmentation of the human annotators, we decide to tag the tarn produced by the speakers. For example, if we have a tarn that is formed by a back channel statement and other dialogue acts, we will say that this is a statement. The second step, in order to reduce the noise in the labeling step, we merge similar dialogue acts activities, at least in the lexical or in the duration. So in this way, we merge statement plus opinion, back channel plus agreement, finding a distribution of 52% of statement plus opinion and 25% of back channel plus agreement. In this way, we compare the complementary part of the switchboard that doesn't contain human annotation with the speech activities that were automatically tagged with our tagger. We found that for statement plus opinion, we found again a decrease for energy and speech rate, and as expected, we found again for back channel plus agreement a decrease in energy. So to recap, we introduced an approach to compare Euclidean distance between average of the speakers into two halves of the conversation using subset of dialogue acts to compare similar speech activities. What we found is that we have a strong effect of decrease of the distance in the second part of the conversation for energy, but contrary, we didn't find any significant effect for F0. As ongoing, we want to use a bigger data set called Fisher that contains 10 times the conversation of the switchboard. Then this has two benefits. The first one is that we can compute reliable measure of average, and that we can we can test our approach in more than two halves. And in addition, we can refine our dialogue acts using more dialogue acts activity. Thank you.